What is a model? We have a very intuitive knowledge of what a model is. Even just looking at a map or something is essentially a model of the world that we're moving in. But we're basically looking at a simplified and a partial representation of reality. And the part where it is simplified and partial is important here because we have to make a decision on how simple it has to be and how partial it has to be. And then we're trying to either accomplish a task or reach an agreement. So we're going through different types of abstraction here. So we can have generalization, we have classification, or we can have aggregation in the abstraction levels that we're doing. So a model would be, for example, a mapping feature. So we actually have an original that we're trying to look at, and we're trying to actually see what is the reality that we're dealing with. And then we're trying to reverse describe that essentially, right? We actually describe the current status quo in a model, and then you actually see what are the issues in there, right? So that would be a mapping feature there. You also only look at the relevant selection, so you reduce what is relevant. And then you also need to actually see, okay, what are we actually going to do with that now? So you are using it in a lot of situations as a discussion basis, as a foundation for agreements, for example. So whatever choices you're making, you're going to be quite pragmatic about that.
We also need to consider
how atomic the actions are in there, right? So because we can always reduce everything further down into even more granular details, down and down and down, but you will have to make a decision of what is pragmatic in your context.
Please consider for a moment the difference between these two models. What would you think is the main difference between them? Pause for a moment and think about that. Now, if you're back, maybe you have realized that on the left-hand side, we have a globe that is describing the Earth. So we actually don't have a model that we're using to create the Earth. We are only describing its properties using that kind of model that we have on the top left side. On the other hand, on the right-hand side, what you see is a model that architects would use in order to describe what the building they are creating will look like in the future. So in this case, we are using models in order to actually describe what we want reality essentially to look like.
We actually have a possibility also in software to say we're going to be descriptive or prescriptive. That's the main difference between these types of models. So you can be descriptive in your models, where you basically say, we are going to use that as documentation. We are looking at what the software already does, and we're documenting that now. Or if you want to communicate the current situation and want to improve on it. There's also mathematical structures modeling, formal verification that people do in modeling, where they actually apply formal methods through mathematical structures. And that is also a descriptive use of models. Then you can have the prescriptive use, which is the reverse. You start with the model, and they're actually going to be a draft. After you have actually looked at the current status quo, the current problem that you're trying to solve, then you create a bunch of models, and you actually look at the alternatives for your solutions. And that would be then a prescriptive use of the model, where in the end, you actually have alternatives that you're offering, and that would then actually be hopefully easy to use. That would be your first objective there. But then you also use that once you've made an agreement as a guideline for the actual implementation step. So you would then, for example, break a model further down into development specifications later. So there the models need to be quite precise in order to actually be good guidelines for the implementation. And then there is something called model-driven development that deals with the idea that rather than coding directly, you create a program and you will have components that include the code, where you have the components and you're using a modeling system in order to actually create the final program, and you're generating the code from the models there. So that is also then a prescriptive use. And rather than having the connection between the model and the code that you have to make sure is always relevant. I mean, that one of the problems you have when you're actually creating this, prescriptive models is that, let's say you create the model today, the development team goes and starts implementing, there's going to be a realization that there will be changes at this point. Now, having to go back to the model and updating that, right, is a constant back and forth. You always have to make sure the model remains current so that it actually remains usable and useful. And in the idea behind model-driven development is that you don't have that, right? You're always working in the model and you always generate your code from that. So that makes it executable in essence. We also have static and dynamic models. So you actually have either the systems that you're modeling or the processes. So in the static model, you actually look at the system itself, the architecture, how, for example, different software components, system components interact with each other. So what is the shape of that system? And that would be, for example, expressed in UML class diagrams. Dynamic models, they look at how does the system work within itself, but also with its boundaries. When we actually look at dynamic models, we also look at inputs that come from outside. We also look at events that the system then triggers that actually link to other systems, for example. And we're actually looking at what the system does and how it functions. Flowcharts and UML activity diagrams would be based on this.